Hi, my name is Jessie Abraham, and I'm going to discuss virtualization. I'm going to give an overview and describe the basics of virtualization, and then how it pertains to healthcare, simulation, and modeling. So the basics of virtualization is that it's the creation of a virtual rather than an actual version of something, such as an operating system, a server, a storage device. It actually goes back to the 1960s, and it was a way of dividing system resources from mainframe computers between different applications. So here we have an illustration of a traditional architecture with and without virtualization. And then on the right side of the screen is, of course, the virtualization layer that is in between the operating system and apps. So you say, why do we need virtualization? Well, the benefits are that there's less physical servers that are required, there's decreased energy and maintenance costs, there's increased efficiency in business, and cycling hardware strategies are much more efficient. There's instant offsite access to applications, and retrieval of files is much easier this way. Additional benefits include better use of system hardware. There's increased power savings because there's less physical equipment that's necessary, and therefore there's reduced carbon footprint. There's also increased recovery and faster recovery of files that may need access, and the flexibility is better, and also you can test systems without damaging the hardware on the computer or the program. So we can review some terminology. I know I needed it, so I'll just briefly go over these words here: server, operating system, software, hardware, cloud, network, and infrastructure. So the servers are high-powered computers or systems that provide us resources and data. Services or programs to other computers, and they're known as clients over a network. So here we see huge servers, and you can see just the enormity of these this equipment. So virtualization of this kind of equipment, you can see, would be time saving, space saving, and also more efficient. Then there's the operating system, which is a program that acts as an interface between the user and the computer hardware and controls the execution of all kinds of programs. So some important functions of the operating system is the management of memory, file management, security, and it can also help detect errors. Examples of this kind of network operating system include Microsoft Windows, Linux, and Mac OS. Another terminology is application software, which is a type of computer program that performs a specific personal, educational, and business function. Each application is designed to assist the end users in achieving certain tasks related to productivity, creativity, or even communication. And these products are like Office, PowerPoint, Word. Then there's the music applications of Pandora, Spotify, and internet browsers like Chrome, Safari, and Firefox. Then we need to know a little bit about computer infrastructure, and that's basically the framework that is the use of different hardware and software components. Computer hardware is a collective term, and it's used to describe any of those physical components of even an analog or a digital computer. And it's a distinguishing term that distinguishes the tangible aspects of a computing device from the software, which consists of written, machine-readable instructions. Then we have the cloud, and the cloud computing is the delivery of on-demand computing services over the internet. Cloud computing can include online data storage as well as media streaming, and there are popular apps that, again, like Spotify and Netflix, that utilize this cloud computing services. Then there's the computer network of systems. So computer networking refers to the interconnectivity of computing devices that can exchange data and share resources. So once again, another way to look at virtualization is the fact that we're using a single machine's hardware to run multiple virtual machines within the system. And there's an allocation of space in the processor, which is the CPU, the RAM, which is the memory, and the storage, which is the data. And the total of this allocation of these resources cannot exceed the CPU, the RAM, and the storage on the computer that is physically present on the hardware. There are different types of virtualization now. There's the server virtualization, there's the operator system virtualization, there's hardware virtualization, there's service virtualization, and there's desktop virtualization, to name some of those types. So if we look at physical server versus a virtual server, we'll see you can see here excuse me, on the physical server, on the first illustration there, you see a server, an operating system, an application, and unused capacity. So when we virtualize systems, we're trying to utilize the full capacity of that equipment or that capacity. So if we add a level of virtualization like type A and then type B, then that capacity is fully utilized. And so what you notice here is there's a operating system, a virtual machine software in type A, and then there's a server and a virtual machine software here in B without this extra layer, and I'll discuss why in the next couple of slides. Here is an illustration of server virtualization where we have the physical standalone servers, the backup, the internet servers, and all these servers here being consolidated into this one virtual server. So you can imagine how much space and time and energy can be conserved if it's consolidated into one system. Here's another way of looking at virtual machines. Here we have 3 virtual machines. We have 3 different servers, but we have one form of data storage. This is one other way of allocating data. And then there's virtual private networks, which I'm using right now to do this program. The fact that my work system has allowed me to use a VPN to get onto the VA network. And so this is the method here from the office to the network access to the VPN connection to the client software. So I can work remotely. So this is one way of virtualization. When I sign off my computer, there's not anything saved on my physical desktop from my work-related information, and that's one of the functions of the security of this virtualization. Here's yet another example of a virtual machine, and this is a lab infrastructure here that we can see. There's a remote team, there's a local team, there's a lab admin. Here we have a centralized lab manager. Here's a resource pool with the virtual machineware infrastructure. Then these are the virtual machines here, and there's a kind of a remote storage library and also a virtual machineware center here somewhere off to the side. So it's not within this space, it's allocated somewhere else. So we have like a cloning here that's happened of these machines here. There's a cloning of the virtual machines. Of the imaging here can be seen as imaging here, similar. So one of the terminology that needs to be understood is the word hypervisor. So hypervisor is that layer of software that creates virtual machines. It is sometimes called a virtual machine monitor, and it isolates the hypervisor operating system and resources from the virtual machines and enables a creation or management of those virtual machines. It creates a layer that runs between the operating system and the server hardware, rather than the operating system and the application. So there's two kinds of hypervisors, and the first one is called Hypervisor 1, or a bare metal hypervisor. It is installed into the hardware of the computer and install instances of servers onto operating systems, and this is mostly used by larger companies, enterprise servers, business type servers. And the top few hypervisors, or these kind of programs, are called Microsoft Hyper-V, Citrix, Zen Server. Those are a couple of them. And so that looks like this, where there's the hardware, there's the virtualization, and we saw this picture in a different way previously. There's the operating system and then the apps. There's another kind of hypervisor, and that is called a hosted hypervisor. And that is, there's an operating system that's installed on the host, such as Linux host or Mac. That's a couple of them. And then underneath is the operating system, and then these are the examples. There's Oracle VirtualBox that people can use from home. There's VMware Workstation, and there's a Mac program called Parallel. So Hypervisor 2 looks like this. There's the hardware, there's the operating system, there's the hypervisor, and then there's the 3 virtual machines. And they can be duplicated many times over as virtual machines. There can be many, not just 3, but this is just the limited view all here. However many a company needs or desires or is feasible. So then healthcare virtualization. So the trends in healthcare we can see is that there's a lot of consumerization, and that now in the last couple of years with care going online and telehealth being very popular, there's a trend for the future for patients to shop for their healthcare needs and not be limited by employer plan selections. So patients will have more options of self-service, self-portals, which there currently exist self-portals for a lot of healthcare, but it's just going to increase. And then there'll be more channels for communication platforms that allow the interaction between patient and provider. Then there's the virtual care that's going to increase. That's an increasing trend. So there's going to be, well, anyway, there's going to be an increase in virtual care. So we're going to see a rise in telehealth, but not only telehealth, but we're going to have like a mainstay of virtual care where patients can make selections for just be at home and dial into their doctors through video conferencing tools, more so than ever. Then another trend in healthcare is analytics. So operational data and clinical data are 2 flavors of analytics in healthcare. And this data that's retrieved will help come up with new therapeutics, treatments, and pharmaceuticals, in addition to a longitudinal profile and patient charts that allow for more personalized medicine, meaning they'll have genomics in their chart, they'll have their history, physical, and their ongoing care. It'll be a longitudinal profile versus just a static profile. And then the wearable devices that are increasing in frequency, like diabetic monitors and blood pressure monitors, that'll be increasing in frequency and will be made more available. Healthcare and virtualization. Data integrity is huge in healthcare, and data integrity allows organizations to set clearance parameters so only the right people have access to certain files. Since data integrity is huge and HIPAA violations are very costly for institutions, data sharing allows healthcare institutions to share documents in compatible formats, so they can be more accessible, as well as efficient and effective communication between institutions taking care of people. And also, as we talked about data security, secure access. So there's a gateway that's established and a secure way to access the remote or local server. And one other way is the personalized desktops, that when healthcare workers move from room to room, they can log into their personal desktops even though they're logging into different computers in the hospital. Another area of virtualization in healthcare is seen in e-scripts. We've gone from paper scripts to e-scripts now. There's prior authorizations that are done through automation and even artificial intelligence. There's health apps out there, one that's coming out that's called Healthy Mice, and that's an app that uses artificial intelligence to monitor patients' voices to screen for respiratory diseases such as pneumonia and asthma. And then there's an agency called KinCore that uses a digital assistant that reminds patients to take their vitals and automatically sends information to their clinician. Then there are digital apps for PTSD, tobacco cessation, and others that help patients manage their chronic diseases and ailments. And then there's one other one that VA just brought out this week. It's called Bridging the Digital Divide, and this is to make healthcare more accessible for all, including the underserved populations. So virtual learning in healthcare. So we see that virtual learning refers to instruction that utilizes computers and the internet from the inside and the outside of facilities. So there's remote access. And then that current virtual learning management systems that are offered, it employs more flexibility and various training modalities. Then there's the virtual medical simulation, which recreates the real world in a three-dimensional format with virtual reality, animation, and virtual patient scenarios. And continuing on virtual reality, there's simulation-based virtual OSCE, or objective structured clinical examinations. And this facilitates core learning for clinical decision-making. And an example of this is like standardized physical assessments and prioritizing care. Another area of virtual reality is the fact that it allows for concepts to be tested by modeling through computer-based strategies and immersive learning. So there's limited patient harm, there's limited cost. And then virtual medical simulation. These are companies and programs in place right now. The healthcare simulation or healthy simulation has programs. VR patients and trauma-enabled virtual reality. Oxford Medical Simulation has various programs. And then the Army has one called Virtual Battlefield, which which is one of many simulations related to all kinds of scenarios in the battlefield. And then there's another one called the Medical Simulation Training Center, which is from the Army as well. So these are just a few that I've mentioned that take virtual reality to the next step and utilizes fully the capacity of virtual medical simulation. And these are my references.